Hello friends, welcome to our YouTube channel. The purpose of this channel is to help students learn from the comfort of their homes. So let's move ahead. The topic for today is Chapter 1 of Class 10 NCERT, that is the real numbers. The fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes, and this factorization is unique, apart from the order in which the prime factors occur. This simply means that every number we can express it as a product of primes, and that prime factorization will not change apart from the order in which the prime factors occur. For example, say we have 540, right? If we find out its prime factors, they would be these things. This would be the prime factors. Now, whenever you find out the prime factorization of 540, it will always be consisting of only these numbers. Yes, what can change is the order, like you can have this, but again you will be having same number of 3s, same number of 2s and same number of 5s, right? So how to find the prime factors? So question number 1, exercise 1.2, express these numbers as a product of its prime factors. 140, 156, 3825, 5005 and 7429. So I'll take just one number and you can do it from there. So let me take 3825. So 3825 is equal to 5 into 765. The first one is a prime number. I'll keep that as such, and then I will further factorize 765. So 765 is equal to 5 into 153. Again 5 will be taken as such, and 153 I would factorize further. 153 is equal to 3 into 1 into 51. 3 is a prime. 51 can be factorized further, and 51 is equal to 3 into 17, right? 3825 is equal to 5 into 5 into 3 into 3 into 17. So these are the prime factors, which are the factors of 3825. So simply the prime factorization of 3825 is 5 into 5 into 3 into 3 into of a number. Question number 2. Find the LCM and HCF of the following pair of integers and verify that LCM into HCF is equal to product of the two numbers. So I'll take again one example. Let me do 510 and 92, that is the second part for you. So first of all, I'll find the prime factorization of 510. So 2 into 255 is 510. 5 into 51 is 255. 3 into 17 is 51, right? And 17 ones are is 17. For 92, 2 into 46 is 92. 2 into 23 is 46. And 23 being a prime number, it will be taken as such. So 510 can be represented as 2 into 3 into 5 into 17, and 92 can be represented as 2 into 2, that is 2 square, into 23. Now to find the LCM and HCF using prime factorization, what do I have to do? To find the HCF. To find the HCF of two numbers, we will first solve the prime factorization of the number and then look out for common factors. For example, in 510 and 92, common factor is this 2. But the difference is that in the first number, there is only one 2, while in the second square, we will always be taking the smaller power. So the HCF of these two numbers is 2. Since we do not have any other common factor, therefore HCF of 510 and 92 is 2. Right? Now to find the LCM using the prime factorization method, what we have to do is we have to take into consideration all the factors, whether or not they are common. And if there are any common factors, we need to take the total, that is the highest power. So 2 and 2 square both are lying in 510 and 92. For LCM we will take the higher power, so I take 2 square. Then 3 is a factor of 510 but not of 92. It will be a part of the LCM. 5 is a part of 510 but not of 92. It will be a part of LCM. Similarly, 17 and 23 will also be factors. So simply I'll get 60 into 17 into 23, and that is 1020 into 23. 1020 into 23 is equal to 23460. This is the LCM of the two numbers. Now the question is, or what we have verify that LCM and HCF is the product of two numbers, right? This put all these in perspective. So LCM into HCF is equal to product of the two numbers. Let us check this. So 23460 into 2, and the two numbers are 510 and 92, right? So 46920, and if even if you find out this, it would still be 46920, right? So 46920, both cases are equal. Therefore we have verified that LCM and HCF of two numbers is equal, the product is equal to the product of the two numbers. Now you need to understand that valid if you have more than two numbers, then this relationship is not valid. So that means for three numbers, if you find out the LCM and HCF, then the product of their LCM and HCF would not be equal to the product of their of those numbers. So next question is, check whether 6 raised to power n can end with the digit 0 for any natural number n. Let me ask you a question. What can you say about the numbers which end in 0? For example, 70, 80, 1000. You can take any number. What can you say about these numbers? Yes, for sure, they will have 10 as their factor, right? It is very, very, very important and necessary that they have 10 as their factor, right? So 10 means they should have 2 and 5 as their factor as well, right? So 6 raised to power n, we know that the prime factors of 6 are 2 and 3. So that means 6 raised to power n has factors of 2 raised to power n into 3 raised to power n. Since there is no 5, no factor of 6 which is 5, and only you have 2 and 3 as its factor, so 6 raised to power n can never end with 0 since it does not have 2 and 5 both as its factor. So there is no 5 in its factors. So 6 raised to power n can never end with 0, right? So next question is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. I'll do one for you. Let me do this one. 7 into 11 into 13 plus 13. So now what is a composite number? A composite number is a number which has more than two factors. It has more than two factors other than itself and 1 are there. So 7 into 11 into 13 plus 13, I can take out 13 as common. I'll be left with 7 into 11 plus 1, that is 13 into 13. It will be 13 into 78. Since this number can be shown as the product of two numbers, neither of which is 1, so therefore it is a composite number. Similarly, you can do it for the other part, right? So last question of this exercise is, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Right? So, one is traveling at a speed that it takes her 18 minutes to drive one round, and the other one is driving at a speed such that it takes him 12 minutes to do the same. Right? So, if they start at the same time, they will meet again after how much time? That required time will be equal to LCM of 12 and 18. So dear friends, you just have to solve the LCM of 12 and 18 and that would be your answer. So after finding it, that which I am leaving for you to do on your own, you'll find that they will be together again at the starting point after 36 minutes. So hope that was informative for you and you were able to do the whole of the exercise 1.2 on your own. For more informative videos, subscribe to our channel and also hit the bell icon so that you are notified whenever we release a new video. Thank you from Horizons.